So let me give you a rundown of what we're doing. You're going to need your calculator, since most of you are going to geometry next year, or you have a calculator handy all the time. It's important to know how to use it and when to use it and what you can use it for. Probably more things than you think, but it's not necessarily obvious. So you guys know this. If you, in your calculator, if you put, let's see, 4 divided by 8, what do you get?
2.
Do it before you say anything. What do you get? You get 0.5. Also, if you put 1 over 2, 1 divided by 2, what do you get?
0.5.
Now we got me saying. Yeah, we also get 0.5. So 4 over 8 reduces to 1 over 2 as the big picture. We've known this for a long time because we know they're equal to each other because their decimals are equal to each other. So we're going to do something similar like this, but with all the radicals. So let's start off figuring out what does root 28 go to. So for mine, I put the square root 28. Okay, and we're going to round to the nearest tenth. Round to the nearest tenth, and this will equal 5.3. Recall how to round. If you said 5.2, don't do that. This is way closer to 5.3. It's 5.29. 29 is pretty close to 30. Don't round it down to 20. Okay. So that's kind of like what we just did here. Okay, we just took the question, we found it as a decimal. Now the next step. Okay. Let's reduce it and show it's the same decimal. So you might recall that we can reduce radicals. There's a chart that we used before. Okay. You're not going to have this chart. I don't want you to get used to having it in front of you because you're not going to have it for the quiz or test, which is next week, by the way, next Wednesday, I believe. So we'll do a test on all this. But remember, you're looking for multiples of perfect squares, multiples of 4, 9, 16, 25, 36, and so on. And you want the biggest possible square root you want to use. So sometimes both 9 and 36 go into a number. You want to make sure you use 36, not the 9. But it's a very similar process. So, well, I'll leave it here. What does what perfect square goes into 28? Okay. So which one of these goes into 28?
4.
4. Yeah. So this is root 4 times root 7, right? Which equals 2 times root 7. So that's kind of like the reducing of from 4/8 to 1/2. We now have reduced it, but now let's verify we do get the same decimals we did before. So let's type this in. Now when you type in 2 times root 7, you're really probably going to figure out what root 7 is and then multiply it by 2. It just works easier with calculators to do it in that order. So go ahead and do square root of 7. Hit enter. Right? And then times 2. And of course we should get the exact same decimal, which we are rounding to 5.3. So these should always match. Just like they did here, 4 divided by 8 is 0.5, 1 divided by 2 is 0.5. Square root of 28 is 5.3. 2 times the square root of 7 is 5.3, because this is just a reduced version of this. And after enough time of doing these, especially in geometry, you do a lot of radicals. You do this all the time. You see probably how easy it is to tell that 4/8 equals 1/2. You're going to be so used to doing this that root 28 and 2 root 7 is going to be just obvious. You're going to be doing so much practice with it that Right now, maybe not. But in geometry, a lot of things use radicals because of what you saw earlier, distance formula and Pythagorean theorem. That's all geometry. Use a lot of radicals. So just trying to get you guys ready for that. And then also, once again, just like yesterday, practice using this symbol correct. What is this symbol called again? Yeah, so you say approximately. Okay, make sure you use that anytime you use a rounded number. So you're going to be getting a lot of long decimals. Anytime you round it, that's when you use this symbol. So also when to use this symbol correctly. I will point out, let's see here, how about number, I think it's 8? Yeah, what's the answer to number 8? 8, right? So I use the approximate sign or the equal sign? Equals, because we didn't round anything. So just like always, when you learn something new, don't start using it on everything for no reason other than it's new. You have to know when to use it. So we didn't round anything. 8 times 8 equals 64, so it equals 8. Yeah.
So we don't have to check it like how we did for number 1?
No, there's no way to check that, right? Only if it reduces can you check it. So if I give you something that's already reduced, there's no way to check it again. Let's see here. Okay, I'll show you a few. Oh, also, keep in mind, what does this number mean? It means approximately that number times itself equals 28. So just to verify, 5.3 times 5.3, it equals about 28. It's not exactly 28 because we rounded it, but that's what that number means. What times itself equals 28. Alright, so let's go to number 3. Now, what perfect square goes into 72 evenly? What's the largest perfect square? And remember, they are 4, 9, 16, 25, 36, 49.
9?
98.
Okay, so what's the largest perfect square that goes into 72? What is it? Okay, so think about that. So yeah, after most of you might come up with 9 and 8 because 9 goes into 8, it's 9 times 8. However, does a perfect square go into 8?
No.
How about 4?
No, because
4 is a perfect square and that goes into 8.
So you have to multiply it by 2.
So that tells you that, yeah, something's wrong. So if you had the chart in front of you, right, you'd have 72, you'd see it's 36 is the largest perfect square, not 9. So you can't always go with, well, that just, I know 9 goes into it, so that must therefore be the largest perfect square. Not necessarily. So here we have root 36 times root 2. As I mentioned before, if you did root 9 and root 8, here's the problem with that, is that root 8 is then going to be root 4 and root 2. So you have to reduce twice. It's kind of like having, let's see. It's kind of like having to reduce twice. Let me come up with a good one here. Like 8 over 16, and then reducing it to, what, 4 over 8, and then reducing it to 1/2. That's kind of like if you chose 9 and 8, that's what you're doing. You have to reduce twice. You have to go to 9 and 8, but then 8 reduces again. What we want you to do is from the very beginning is divide top and bottom by 8 and get 1/2 and skip this. Same thing here. By taking the largest perfect square, it reduces it all the way from the very beginning. Fewer steps, same answer. And of course, still go ahead and verify. Let's see here. What's the square root of 72? Okay, type it in. And we got 8.5. And then verify that your reduced answer is approximately the same decimal. And remember, do the radical first, radical 2, and then times 6. So about 8.5. So again, these should match. So up and down your paper, I'll see the same decimal twice, one for the original and one for the reduced. There are a few people today that have just gone through and used a calculator and they got the decimal for all the original questions. They didn't reduce anything. They get zeros. They're not really doing the work. So make sure you do the reducing as well.
I did 8 and 9, and I still got 8.5.
Yeah, but you need to reduce it all the way.
But I did the square root of 8 times 3, and I got 8.5.
8 times 3 is
Square root.
24.
No, square root of 8 times 3. And I got
Yeah,
8.5.
but again, it's kind of like saying your final answer is 4 over 8, and you're saying that's all the reduced. You have to reduce the root 8 all the way and get the 6 root 2. It's on the right path. That's why you don't want to use 9 and 8. You want to use 36 and 2. You haven't reduced it all the way. Okay? So use, whenever you think 9 goes into the number, check 36. Whenever you think 4 goes into the number, check 16. Because 4 goes into 16 and 9 goes into 36. So anything that 36 goes into, so will 9, and it could be deceiving. Okay? But you have to check them. Alright, last one I'll show you is like when you get down to number 7. What does this equal approximately? Okay, plug it in, see what you get. Now, does this reduce? Does this reduce? What perfect square goes into 30? Does 4? Does 9? Does 16? Yeah, so just like always, sometimes you get a fraction that's like 4/7 and it doesn't reduce. So just like fractions, not every radical reduces, and that's it. So in this case, there's no second part that's going to be a reduced version. It's already reduced. So you'll have all the same situations you have with fractions. Sometimes they're reduced, sometimes they're not. Sometimes they're easy to divide and get a decimal, sometimes not. You're going to have all the same similar situations with radicals. And it's just really getting good at knowing, after doing these enough times, just getting used to it, and you're getting really familiar with, okay, 28 is 2 root 7, and root 8 is 2 root 2. You just get used to seeing the same answers over and over. Okay. I will go over a little bit of 4th grade, 5th grade math with you right now, just to recall how to do when you have larger numbers. If it's not obvious right away, what you want to do is you want to do something you did in elementary school called prime factorization. So you break it up into all prime numbers. So 180 is the same as 18 times 10. Let's see here. 18 is going to be 2 times 9. 10 is going to be 2 times 5. And then all these are prime except for 9. 9 breaks up into 3 times 3. And what you want to do is look for pairs of numbers. So like here, we know 9 goes into 180 because there's a 3 times 3. We also know 4 because there's 2 times 2. There's 2 2's, so you're looking for pairs. So 4 and 9 go into 180, which means this is 4 times 9, right? Here's the 4, here's the 9, and here's the 5. And then the 2 perfect squares, that's 36 times 5, and that will help you reduce larger numbers. You just have to use prime factorization and look for pairs of numbers. 3 times 3 is the 9, 2 times 2 is the 4. Sometimes there's one perfect square or one pair of numbers. Sometimes there's 2. This time there's 2. And then if you have multiple perfect squares, multiply them together. So you notice how I didn't multiply the 5 with 9 or the 5 with 4. These are on that list: 4, 9, 16, 25, 36. You will not have access to this chart that you had before. Okay, so you're going to have to use this prime factorization whenever needed in order to reduce. And of course, you can check it with your calculator and verify. They should come out to approximately the same decimal. Okay. Lastly, on the back are some word problems. Just recall that, like on these, the format is this: 1 over A plus 1 over B equals 1 over T, where A and B are the individuals, and then this is the total. Alright. And then there's two problems that they give you the two individuals, and the next two problems they give you one individual and the total. Of course, use your calculator on these. There's some decimals in there, but you have calculators, so that's fine. Okay, you guys work on that, and we'll collect it at the end of the period.